Hey everyone, and welcome back to The Explainer. So today we're actually zeroing in on a very specific date, June 6th. Now following the structure outlined in our source document ENGV, we're going to see why this isn't just another square on the calendar. It is, quite literally, one of the greatest dates in the entire history of mathematics, and I'm going to show you exactly why.
You see, on this single vintage calendar date, across entirely different centuries and completely different countries, some genuinely brilliant minds were born or passed away. Minds that completely changed the world we live in right now. It's kind of mind-blowing how one day on the calendar connects so much of the technology and the invisible systems that power our modern lives.
Okay, let's dive into this. We're about to meet four extraordinary people plotted right here on this timeline. One date. So many incredible stories. Let's peel back the curtain and see who's hiding behind these question marks, shall we? But first, a quick question for you. Why does your phone's GPS always find the fastest, exact route even when you're driving through hundreds of twisted, confusing roads? Like, how does it actually pull that off?
Well, the answer goes all the way back to June 6, 1436, with the birth of a brilliant astronomer named Regiomontanus.
So here's what he did. He realized that to even begin to understand the vast cosmos, he needed a highly structured system. So he looked up and mapped the night sky using something incredibly simple: triangles. He calculated distances and angles between stars, and by writing this massive book on these triangles back in 1464, he systematically organized the rules of trigonometry. But think about what that actually means for us. He literally took the overwhelming chaos of the night sky and broke it down into readable, manageable, three-sided shapes. Today, your GPS uses those exact same mathematical rules. It calculates angles between multiple satellites hovering way up in space and your phone down on the ground, just to pinpoint exactly where you are.
And this brilliantly illustrates his whole philosophy. As he insisted, you must read these theorems about triangles. He just knew that the very math used to chart the heavens would be the key to unlocking the world. And today, well, it's exactly what navigates our cars.
All right, same date, exactly 406 years later. A completely different country and an absolutely amazing story of human resilience. Here comes our next mind.
But first, I really want you to think about this. Have you ever wondered how someone who cannot see can still read and write complex geometry and scientific equations? Like, how do you experience the highly visual world of math without your sight?
That brings us to our next stop. Born on June 6, 1842, meet the outstanding Cambridge mathematician Henry Martyn Taylor.
Now, Taylor faced a massive personal challenge that honestly would have stopped most people right in their tracks. While he was right in the middle of editing a famous, highly complex geometry textbook, he completely lost the sight in both of his eyes. His world went entirely dark. But he didn't stop. Actually, he took that personal tragedy and poured all his remaining energy into inventing a highly comprehensive Braille mathematical notation. Think about the intense spatial reasoning required for geometry, the shapes, the angles, the intersecting lines. He figured out a way to translate all of that visual data into a tactile language you could literally feel. He created this incredibly empowering tool that allowed blind students everywhere to read advanced science and math independently.
As historical records of his life's work note, he devised a Braille system to allow mathematical works to become available to the blind. His system was so brilliant and so intuitive that it quickly became the universal standard across the English-speaking world, a real game changer.
Okay, we're jumping forward across the timeline again. It's still June 5th, but now we're entering the modern age. Think about your phone again for a second. How does a single social media post reach millions of people instantly? What exactly is this invisible digital web we rely on every single day to connect with our friends and family? The answer to that traces back to June 6, 1933, with the birth of Víctor Neumann-Lara, a brilliant and deeply beloved Mexican mathematician.
He was an absolute pioneer in graph theory. And if you aren't super familiar with that, graph theory is basically the mathematical study of networks and connections. It looks at how different points or nodes link together to form a larger system. But Neumann-Lara didn't just see this as dry, boring math. No, he saw these complex networks as things of incredible beauty. In fact, he even insisted on using feminine Spanish nouns to describe them, treating these mathematical graphs almost like poetry. By giving his students open-ended mysteries to solve, rather than just making them memorize encyclopedias, he pushed the boundaries of how we map connections. Today, his theoretical work helps us understand the massive interconnected webs of data that run our internet, manage global logistics, and yes, power our social media.
He was famously known to say that graphs were objects of such beauty that they should have a feminine name. He really saw the art in the math. And every single time we connect online today, we're relying on the beautiful networks that he studied so passionately.
Let's move to our final stop and see how this all builds together. But actually, scratch that. This time we aren't looking at a birth date. We are looking at the day a great mind passed away.
Before I reveal who it is, let me ask you this. Why is it actually safe to send your passwords, your bank details, or your private text messages over the internet? Like, what's stopping hackers from just reading them in plain text?
Well, the security we enjoyed today owes a tremendous amount to Adrian Albert. He was an American mathematician who passed away on this exact date, June 6, in 1972.
During World War II, Albert poured his brilliant mind into cryptography. He used advanced, highly complex algebra to tackle immense military problems, creating codes that the enemy simply could not break. The math was incredibly dense, dealing with abstract structures and matrices. So the crucial point here is that his wartime work didn't just, stay in the 1940s. The complex algebra he explored laid the direct foundation for the digital encryption we use all the time right now. The mathematical shields that secured military secrets back then, they are the exact reason our smartphone security, our encrypted text messages, and our banking apps actually work today.
Historical accounts kind of casually note that another interest of Albert's was that of cryptography, which honestly sounds like a massive understatement today, because that interest helped forge the unbreakable mathematical shield that protects literally every secure message you send.
And that brings us to our fully populated timeline. Just look at this. June 6th connects a 15th century astronomer, a blind 19th century geometer, a Mexican network pioneer, and an American codebreaker. All of these completely disparate historical figures pulled together onto one single connective line.
Because ultimately, every person we met today, across all those different centuries and different countries, they all asked the exact same fundamental question. What is the pattern hiding inside the chaos? And because they asked, because they were brave enough to look for those patterns in the stars, in the dark, in the web, and in the codes, our world today has GPS, accessible science, the internet, and a safely connected digital life. So it makes you wonder, what patterns will you look for today? Keep wondering, and I will see you in the next explainer.